Alright, and welcome to the video for lesson number 4, the definition of a parabola. So in class we did a couple different things with the definition of a parabola. One of them we understand is if we have the focus and the directrix, we have an idea of where the parabola is going to lie. So for example, in number 1, it gives us the directrix and it gives us the focus. So what we should know is that the vertex is somewhere right in between those two. So the point I'm making here, that should be the vertex. Also, the parabola is going to go away from the directrix and kind of enclose the focus. So it should look something like this. This would be an example of a parabola that is concave down. Let's look at number 2. It says, derive the equation for a parabola whose focus is 0, 4, and the directrix is the x-axis. The x-axis is really the equation y equals 0. So when I look at my equation that we derived in class, it was y minus the directrix is equal to the square root of x minus the x value of the focus squared plus y minus the y value of the focus squared. Well, if I put all of my information in, I have y minus 0, which is just y. I have x minus 0, which is just x, and y minus 4 squared. If we then square both sides to get rid of the radical, we get y squared is equal to x squared plus y minus 4 squared. Now, y minus 4 squared, we can go through and do the whole box method thing. If you understand what I was doing in class today, where we double the middle number and multiply the number by itself to create the trinomial, that makes us a lot easier. So I have y squared equals x squared plus y squared minus 8y plus 16. One of the basic concepts of algebra is if I see the same term on both sides of the equation, it cancels. So if I move the y term to the other side, because remember we want to get y by itself, I get the equation 8y equals x squared plus 16. Divide everything by 8, and I get y equals 1/8 x squared plus 2. The next one says the directrix of a parabola is equal to 1. Find the coordinates of the focus. Well, the nice thing about focus and directrix is they're all the same distance apart from the vertex. So essentially this is a fancy way of me saying, do you know how to find the vertex of that parabola? So to put this in vertex form, I'm going to start by adding a 24 to the other side. And I can divide everything by 8. So that gives me y equals 1/8 times x plus 2 squared plus 3. The vertex of this parabola is going to be the point -2, 3. Also, since the term in front of the parenthesis for x plus 2, the a term, is greater than 1, I know that this, is greater than 0, I know this is going to be concave up. So if I do a quick sketch of this parabola, well, y equals 1 is here. Whoa, that was a bad line. The vertex was -2 up 3. So that means the parabola is going to open like this. And the focus is going to be somewhere inside that parabola. So what I'm essentially asking you to do here is say, well, how many boxes do I have to count to go from the directrix to the vertex? Well, that would be 2. So if I go 2 more boxes up, I would be at the focus. So the focus is going to have the same x coordinate as the vertex. It's just going to be 2 units above the vertex in this case. So it would be -2, 5. No fancy algebra or anything we have to do there, just essentially, do we understand what the graphs look like? The next one gives us the directrix and it gives us the focus. So we know the focus is the coordinate 1, 3. And the directrix is y equals 1. So we could derive the equation from there. So that would become y minus 1 equals the square root of x minus 1 squared plus y minus 3 squared. If we square both sides, we get y minus 1 squared equals x minus 1 squared plus y minus 3 squared. Again, we have to multiply out the terms with y. The parenthesis with x minus 1 squared, we're not going to change that because I want to know what the vertex is. The vertex should come out to be the coordinate of 1, 2. So we'll see once we get our answer here. So if we multiply these out, again, either using the tabular method with the boxes or using the trick we showed you in class, we should get that expression. Again, the y squareds cancel. Same thing on both sides of the equation. That's nice. Add the 6y. So I get 4y plus 1 equals x minus 1 squared plus 9. If I subtract 1, I get 4y equals x minus 1 squared plus 8. Divide everything by 4. And I get the final equation, y equals 1/4 x minus 1 squared plus 2. The vertex is 1, 2, like it should be. So that's one nice thing about leaving these in vertex form. We kind of know what the vertex is right away without having to do much thinking. This is essentially the same question, but they're not using those keywords, focus, directrix. So one of the hard things about this course and the Regents exam in June is when you see something like this, you have to then understand what they're actually asking you. All right, it's not going to be in the lesson on focus and directrix. It's going to be a random question on a test. So it says find a set of an equation that's equidistant from this point and this line. Well, that point is the focus, and this line is the directrix. So if we make our equation, we have y minus 5 equals the square root of x minus 4 squared plus y minus 3 squared. Square both sides again, so I have y minus 5 squared equals x minus 4 squared plus y minus 3 squared. Multiply everything out. Again, tabular method or the trick. To review the trick real quick, I know that this first one's going to multiply out to that because negative 5 times 2 is negative 10. Negative 5 times itself is 25. So I know what the numbers are going to be. It's essentially, I'm reverse factoring, if you will. Y squareds cancel. Move the 6y. So I have negative 4y plus 25 equals x minus 4 squared plus 9. Move the 25. Negative 4y equals x minus 4 squared minus 16. And then divide everything by negative 4. So we get our final answer of y equals negative 1/4 times x minus 4 squared plus 4. Double negative makes the plus there. And I know a ton about this graph without actually even using my calculator. I know if I was to go through and graph it, the vertex is going to be positive 4, positive 4. And because the term or the number in front of the x minus 4 is negative, I know it's going to be concave down. I know the focus is 4, 3, so it's going to be like right here. And I know the directrix is y equals 5, so it's going to be right above it. Now, they didn't ask you to do the sketch, but that kind of helps understand kind of what we're doing here today. Hopefully this video helps. If you're still struggling with this, we are going to practice in class tomorrow in the non-accelerated class. If you're in my accelerated class and you're watching this video, I know we showed you a couple different ways of actually going through and solving these. So if you were using the formulas that we did in the extension lesson, that's totally going to work. You just have to kind of make sure that you're getting the same equations that I am. Hopefully this video helps, and good luck.